like to find the length of the curve given here, y equals 2/3 x to the 3/2 minus 1/2 x to the 1/2 plus 3 over the interval from 1 to 9. This is what the curve looks like. It's not a straight line, it's definitely curved, but it is fairly similar to a straight line. So if I actually do draw the straight line, I can get an approximate of what the curve's length should be. And this will help me figure out if the answer that I get at the end is reasonable. So this isn't exact, but this is about at the point 1, 3. And up here is about the point 9, call it 19. Distances between these types of points are fairly easy to find. These are approximate, but it'll give me at least a handle of whether I'm in the right spot or not. And so I take the square root of the differences of the x-coordinate squared and the y-coordinate squared. So y-coordinates give me 16 squared. The x-coordinates give me 8 squared. And so this is going to be equal to the square root of 320, which is approximately equal to about 17.9, give or take. I want to emphasize again that this is not exact, but this is an approximate, and so it'll tell us if our answer is close, or maybe not. So to find the exact answer, we have a formula that involves the integral. It's going to be the length is equal to the integral from 1 to 9 in this case, of the square root of 1 plus the derivative of y squared with respect to x. In order to actually compute this integral, we need to know a couple of things. First things first, we need to know what is the derivative of y. Then we'll have to square it, we'll have to add 1, and see if we can actually take the square root. So we start with y prime. In this case, y prime is going to be x to the 1/2 minus 1/4 x to the negative 1/2. Once we have the derivative, then we need to square this. So we're going to take this and multiply it by itself. We can use the square formula, or you can just multiply the two binomials, and what you end up with is x to the 1/2 squared, which is x. Then I'm going to subtract twice the product of the two, and luckily x to the 1/2 times x to the minus 1/2 is just 1. So I get twice times 1/4, which is 1/2, with no powers of x. And then finally, I take the last term squared, which is 1/16 x to the negative 1. Multiplying out the square gives me these three terms. And to remind myself for later, because it's going to come up again, I'm going to write down exactly what this is squared. This is x to the 1/2 minus 1/4 x to the negative 1/2 squared. So now, for the formula, I need to add 1 to my derivative. It's 1 plus y prime squared. And so what that's going to affect in my trinomial is not the x term or the x to the minus first term. It is just the middle term. I get x to the 1/2, or x plus 1/2 plus 1/16 x to the negative 1. And when you look at these two terms, these two trinomials right next to each other, the only thing that's different is the constant term, and it's only different by sign. And so this is also a perfect square, and it's a perfect square with the plus instead of the minus. And so this is really good, because when I take the square root, it's going to allow me to work with that square root. So now I take this term and I plug it into the formula, and what I end up with is my length. My length is going to be equal to the integral from 1 to 9 of the square root of this term I just found. And so that's x to the 1/2 plus 1/4 x to the negative 1/2, all squared. And this square is under the square root. Typically, when you take the square root of something squared, you have to leave some absolute values around it. But in this case, because I'm only working with positive numbers, I don't have to worry so much about that. And so I end up with the integral of x to the 1/2 plus 1/4 x to the negative 1/2. And so we can antidifferentiate this, and we end up with our actual answer. My antiderivative is 2/3 x to the 3/2 plus 1/2 x to the positive 1/2. And I'm going to evaluate this between 1 and 9. And when you do, you end up with 55/3. Now let's see how this compares to our original estimate. Our original estimate was 17.9. 55 thirds is 18 1/3. which is just a little bit more than 18. And so I would say our estimate is actually pretty good. And it makes me believe that the answer that we get out of this is actually correct.